Hello and welcome to KineMark. In this episode, we shall discuss a brief summary of multi-stage switching. In the classroom, we've covered two-stage switching with a mixing stage, and then three-stage switching. So quickly, without wasting much time, let's jump into the discussion. We recall that in class, to design a certain N by N switch, so I mean capital N by capital N switch using small n by small n switches. First, you would divide the number of inlets, which is represented by capital N, by small n to give you the number of switches you would need in the first stage. So we have this n by n, which is the small n by small n. And then we divide capital N by small n. Now, if capital N is equal to the square of small n, then it means that we are going to have n switches or small n switches in the first stage. And then in our secondary stage or in the final stage, we will do likewise. Alright, so we have also capital N divided by small n, and then we get small n number of switches in the second stage. So we interconnect them like this. And then first, to find the number of switches in this system or in this network, you realize that in the first stage we have n number of switches or small n number of switches, and then in the second stage we have small n number of switches. So we can conclude that for the condition when small n is equal to the square root of capital N, then the number of switches is always going to be 2n. Okay, then to find the number of cross points, we learned in class that you can multiply or you can find a cross point in one switch by multiplying the inlets and the outlets. Okay, then you multiply that number of cross points in one switch by the number of switches in that entire network. Okay, so you multiply the number of cross points in one switch by the number of switches in the network. So you realize that the number of cross points for the two-stage network is going to be 2n. Now n times n will give you n squared cross points in this switch. So 2n times n squared, which becomes 2n cubed. Okay, so in a two-stage network, when your small n is equal to the square root of capital N, then the number of switches can be found using the formula 2n, and the number of cross points can be found using the formula 2n cubed. So for instance, if you were to design a 121 by 121 switch using 11 by 11 primary and secondary switches, the number of switches is going to be 2 times small n, which is 11. That gives us 22. Then our total number of cross points shall be 2 times 11 cubed, which gives us 2662. So for the condition that your small n is equal to the square root of capital N, then the number of switches will be 2 times n, and the number of cross points is going to be 2 times n cubed. Let's now add a mixing stage to the network. So you would have your original two-stage network still for when your small n is equal to the root of capital N. You have your original two-stage network and you realize that you have n switches in both stages. Then we add our mixing stage. In the mixing stage, we are going to have the same small n number of switches like this. So now to find the number of switches in this network, first you are going to need n new switches added to the original two-stage system. But now our total number of switches, you realize that you have small n number of switches in the mixing stage, small n number of switches in the secondary stage, and small n number of switches in the primary stage. So in total, we have 3n switches. Then to find the number of cross points in this network, we shall have n squared cross points in one switch. Then we shall multiply that by the number of switches in the network. So the number of cross points is going to be 3n times n squared, and that will give us 3n cubed. So for instance, if we have our original 11 by 11 primary and secondary stage system, then we want to add a mixing stage to the system, we shall have 33, because 3 times 11 is 33. So 33 switches in our system, and then we would need 11 new switches. And then to find the number of cross points, we are going to have 3 times 11 cubed, and that gives us 3,993 cross points. For the mixing stage, remember, you are always going to get n alternate paths. So the number of alternate paths in our system, since we are using 11 by 11 primary and secondary switches, is going to be 11. Again, the size of the mixing stage, or the size of the two-stage network with the mixing stage, will be the same as your ordinary two-stage network. So if it was 11 by 11 with the mixing stage, the size is still going to be 11 squared by 11 squared. So we simplify that to 121 by 121. Then let's move to the case of the three-stage network. In the three-stage network, the rule says we should treat our n squared by n squared two-stage system as a block on its own. So n inlets. So we shall treat this as one block on its own. Then we are to attach it to n squared new n by n switches. And then we shall copy our block n times. We have our last block here, like this. We have n of these blocks in this first stage. So now in this three-stage network, to find the number of switches, you realize that this is an original two-stage block, and in this original two-stage block, we have n in the first stage, n in the second stage. So we have 2n in one block. So 2n switches in one block. But in this stage, there are n of the two-stage blocks. So it means you are going to multiply this 2n by n. After that, if you come to this final stage, you realize that there are n squared of the n by n's. So we are going to have all this plus n squared. So if we simplify, we're going to have 2n squared plus n squared, and that gives us 3n squared. Then to find the number of cross points, we are going to have this 3n squared as the number of switches in the system multiplied by the number of cross points in one switch. So in this one, we can take this for example. We're going to have n squared number of cross points. So by multiplication, we're going to have 3n squared times n squared. That gives us 3n to the power 4. Note the indices are only dealing with the n's and not the entire expression 3n. So it is 3 times the square of n, 3 times the fourth power of n. So for example, if we are to implement a three-stage network using 11 by 11, then we are going to have 3 times 11 square switches in our system, and that gives us 363 switches. And then the number of cross points is going to be 3 times the fourth power of 11, and that gives us 43,923. So we've touched on the number of switches for a two-stage network, the number of cross points for a two-stage network, then the number of switches needed for a two-stage network with a mixing stage, and the number of cross points needed for a two-stage network with a mixing stage. Then now we've also touched on the number of switches needed for a three-stage distribution type network, and the number of cross points needed for the same network. Remember, in the mixing stage, you are introducing n alternate paths, and you're going to have n new switches. Then again, for the mixing stage and the two-stage network, the condition for this formula is that small n must be equal to the square root of capital N. I hope this video has been helpful, and we shall be back again with more comprehensive tutorials. Thank you.